Alright, here we're looking at section 7.2, and our essential question is how can you multiply two polynomials, right? So in our previous lesson we learned about adding and subtracting, and now we're going to be multiplying those polynomials. So our learning targets are multiply binomials, and then multiply binomials and trinomials. You'll see I've gotten rid of one of the learning targets because it's already taken care of in both of these, and it can become confusing, so we're just going to kind of simplify things a little bit. So usually we skip these explorations, but I wanted to show you this one really quickly. Here we're looking at multiplying, and we're using those algebra tiles, which we can always use, right? So first we're multiplying x plus 3, which I see here the x is green and my plus 3 are down along the side, times x minus 2, which I put those tiles across the top. And then I can multiply each individual piece. So I know that x times x is going to be x long on the side and x long on the top. So this becomes an x squared piece. Then I see that I have 1 times x, which gives me x, 1 times x, which gives me x, 1 times x, which gives me x. This x now I'm multiplying times a negative 1, which gives me a negative x. Same thing here. And I know that 1 times a negative 1 gives me a negative 1. So now I can go through and I can see everything that I have now that I've filled in my chart with the different blocks, and I see that I have an x squared, and I know that a positive x and a negative x cancel each other out. So this red one will cancel with this green one, and same with this green one and this red one. So I'm left with 1x, and it's positive because it's green, and then I have minus 6. So I can go ahead and I can multiply these by using my algebra tiles as well, but we're going to look at a couple more ways to do that. So here we're going to find these products, and remember that product means multiplying. So for part A, we're going to do this horizontally. So I know that I can take the first term in my first polynomial and multiply it by everything in my second polynomial, right? So then I'm going to take the second term in my first polynomial and multiply it times my entire second polynomial. So now that I'm here, right, now I can go ahead and I use the distributive property, and I can distribute my values. So I end up with x squared, and then x times 5 is 5x, plus 2 times x is 2x, 2 times 5 is 10. So now that I've done the distribution, right, because I just did this side as well, I see that I have two terms here that have the same variable and the same exponent, so I can combine those terms. So I end up with x squared plus 7x plus 10. So now that is my fully simplified answer when I multiply these two together. So now let's look at part B. We're going to do this problem vertically, right? Because here we did it horizontally, we just multiplied it across. So now we're going to do this vertically. So I take my first polynomial, and then I take my second polynomial. The big thing is I want to make sure that these are aligned, right? So my constants are aligned, my first term is aligned. If I have an x squared, those are aligned. And I can go ahead and multiply them just like I've always done, right? I always take the furthest right term on the bottom and start by multiplying that. So I know a negative 4 times 3 is a negative 12, and a negative 4 times x is a negative 4x. So then I know I always have a placeholder, right? Just like our traditional multiplication. X times 3 is 3x, and x times x is x squared. So now I can go ahead and I add these together. So negative 12 plus 0 is negative 12. Negative 4x plus 3x is a negative 1x, and then x squared plus 0 is x squared. So I end up with x squared minus x minus 12. And that is as simple as I can get because all of my terms have different variables with different exponents. So I know I'm simplified. So when I can do either of these either way, it does not matter at all which one I do. So here's another problem, right? I want you to go ahead and try this one. We're going to actually use this one using a table, right? Because here's our third method of what we can do. So I'm going to take this first polynomial, right? And I'm going to write its terms kind of up across the top, and I'm going to space them out a little bit. Oh, and that is not a 2. That is a 3. Then I take my second polynomial and I write my terms kind of along the side. So now you'll see I have this table. So now I can multiply each individual piece. Well, I know that 2x times x is going to give me 2x squared. I know that negative 3 times x gives me a negative 3x. I know that 5 times 2x gives me 10x, and 5 times a negative 3 is a negative 15. Well, now I have all of these different pieces, and I know I want to write my polynomial in standard form, so I start with the largest exponent first, which I see here is a 2. So I end up with 2x squared. Then I want to look at just my x's, and I see I have 2 of those. I have one right here, and I have one right here, so I need to combine those. So I know that 10x minus 3x is a 7x, and then I want my constant, which is minus 15. So now I have my fully simplified polynomial from multiplying. So here are 3 different methods you can use, right? Here we used a table. Back on this example, we looked at multiplying horizontally, and we looked at multiplying vertically. All 3 of those methods will get you the same thing. So here are a couple of monitoring progress that I want you to try and see how you can do. So this first part is asking you to use the distributive property, right? And that's multiplying horizontally. And then these number 3 and 4 using a table. So try each way and see which way works best for you. So you'll see that we're skipping this next core concept, and here are a couple of problems that I actually want you to try. The answers are in your book, but I want you again to try and do these horizontally or vertically and see what you end up with. So now here's our next problem. This is going to be example number 4. So you'll see the difference here is I have a binomial, right, which means I have 2 terms, and I have a trinomial, which means I have 3 terms. So let's go ahead and do this one 2 different ways so we can see that it works either way. First, I'm going to do it horizontally. So I have my x, which is that first term, and I multiply it by everything in my second polynomial. Okay, so then I'm going to take my second term in my first polynomial, and I multiply it by the entire second polynomial. Okay, so now that I'm here, I use the distributive property. So x times x squared is x cubed. X times a negative 3x is negative 3x squared. X times a negative 2 is negative 2x. 5 times x squared is 5x squared. 5 times a negative 3x is negative 15x. And 5 times a negative 2 is negative 10. So now I want to combine the terms and write my final polynomial. And again, I always want to do this in standard form, so I start with the largest exponent first, which is that x cubed. And I'm just going to cross them off as I go. So now I'm going to be dealing with my x squareds, and I see I have one right here and one right here, so I need to combine those. So a negative 3x squared plus 5x squared gives me 2x squared. So now I've taken care of those 2 terms. So now I'm dealing with x's. There's one right there and one right there. So a negative 2x minus 15x gives me a negative 17x. I can cross those out, I've taken care of them, and all I'm left with is my constant, which is minus 10. So here is my fully simplified polynomial. So let's try and solve this one and multiply this one going vertically instead. So when I'm multiplying vertically, just like I did when it was just numbers, I try and put the biggest one on top. Right? So I have x squared minus 3x minus 2 is going to be on the top because it's the larger polynomial. And then I line up what I have for my second polynomial, right? My constants under my constants, my x terms under my x terms, and any x squared terms under my x squared terms. And you'll notice that I'm being very careful. You never use an x when we're talking multiplication because the x actually stands for something. We want to use a dot or a star. So now I just multiply like I have been. I take my furthest right term on the bottom and go from there. So 5 times a negative 2 is negative 10. 5 times a negative 3x is negative 15x. 5 times x squared is 5x squared. So I have my placeholder, right, because I know that there's going to be nothing there. So x times a negative 2 is negative 2x. X times a negative 3x is negative 3x squared. And x times x squared gives me an x cubed. So now that I have that done, I can go ahead and I add my terms together. Negative 10 plus 0 is negative 10. Negative 15x minus 2x is negative 17x. 5x squared minus 3x squared is 2x squared. And x cubed is out here with adding to nothing. So you'll see I get the same answer either way. So it's really all about comfort, which way you're more comfortable with. So try them both and see which one works best. So now we're going to look at example number 5. And this is kind of using real-world situations and using other information to get where we need to go. So in hockey, a goalie behind the goal line can only play a puck in the trapezoidal region. Right in a trapezoid is this shape right here. It's also broken down a little bit larger down here. So first I need to write a polynomial that represents the area of the trapezoidal region. So first I have to figure out what the area of a trapezoid looks like. And I know that it's going to be 1/2 times the height, and then I multiply that times the first base plus the second base. So now that I have this, I can go ahead and plug in the information that I know. So I've got 1/2. The height is this x minus 7. The bases are x plus x plus 10. Okay, so I know the first thing I want to do is I want to simplify this part here because I'm just adding, and so I want to get everything as close together as I can. So my 1/2 stays the same. X minus 7 I haven't done anything with. Now here I have x plus 10, which gives me 2x plus 10. So now I want to go ahead and multiply these two together. I like to multiply the polynomials first and then deal with the numbers out in front later. So I'm going to stick with this part right here and multiply these out. And I'm a person that likes to go horizontally, so I'm going to do that. And you'll see why again in just a second. So I take my first term, which is an x, and I multiply it by my entire second polynomial. Then I take my second term in my first one, which was a -7, and I multiply it by the entire second polynomial. Now I use the distributive property, and I can't forget that my 1/2 is out front here. Now I use the distributive property. So I've got x times 2x is 2x squared. X times 10 is 10x. Now here's where this gets tricky. This -7 I have to multiply by everything. So a -7 times 2x is -14x. And a -7 times 10 is a -70. So now I want to go ahead and simplify and combine my like terms. So I have 1/2 times the quantity 2x squared minus 4x minus 70. So now from here, I can go ahead and I can multiply this 1/2 in, right? Because it's the only thing out here now. So again, I use the distributive property and multiply each term by 1/2, so I end up with x squared minus 2x minus 35. Now I'm completely simplified, and that's the equation for finding that area, right? So that was part A, write a polynomial that represents the area. So that's what I've just done. So now I'm supposed to find the area of the trapezoidal region when the shorter base is 18 feet. Well, and I'm told in this picture that the shorter base is x, right? Here I'm told. So now I'm going to go back down to my polynomial, and I'm going to plug in x for plug in 8 for all of my x's. Or 18, I'm sorry. So we are going to have 18 squared minus 2 times 18 minus 35. So all I've done is I've taken wherever there was an x and I've plugged in the information that I was given up here, which I'm told when it's 18 feet. So now I can just calculate and figure this out. And I know that 18 squared is 324 minus 2 times 18 is 36 minus 35. So I end up with 253. Okay, so this area, my final area, is 253 square feet. And I know that because I was told that we were dealing with square feet up in the problem. And I always want to label my answers based on what's in the problem. Okay, so now we've worked through all of the examples. So here's a couple more monitoring progress. These are going to be really important for you to do. Make sure that you can multiply when I have a binomial and a trinomial together. And even if I have a trinomial and a trinomial, try a couple of big ones before you move on to the practice problems. So let's look back at our learning targets. So multiply binomials. And we looked at several ways we can do that. We can either multiply them going horizontally or vertically or using a table. Either way works. And then our second learning target is multiply binomials and trinomials. And we looked at that going both horizontally and vertically. Now really, if you wanted to use a table here, you could as well. It'll work exactly the same way. So now that we've gone through these examples and you've walked through them and seen them in action, go ahead and try working on that homework for 7.2.